So in this video, we are going to be doing the taco cart problem. So in this problem, it asks us how far down the road should the cart be placed so both people arrived simultaneously. In order to think about this, we really want to consider the times. The time for the first person to go from their current beach location to the road, I would consider time 1. And time 2 would be the time it takes to go from the intersection of the road and the beach down to the new location of the taco cart. The distance is 325.6 from the beach to the road, measured perpendicular to the road, and the traveling rate across the sand is 2 feet per second. So therefore, we can find the time by dividing the distance by the rate. Time 2 can be found in a similar fashion. X is the distance now from the corner over here where it intersects the road and the new location of the taco cart. And along the road, we can travel at a rate of 5 feet per second. Next, we need to consider time 3, which would be the time to travel along the route from the current beach location to the new location of the taco cart. Well, again, that distance is going to be, well, first the distance will have to be calculated, but that time can be calculated using the distance over the rate. The distance is going to be found by doing the distance along the one side of the right triangle, squared, plus the distance on the other side of the right triangle, squared, and then, of course, take the square root by Pythagorean theorem. But we're not looking for just the distance. That would be the distance from the current beach location to the new location. We want to divide by the rate, which is 2 feet per second along the beach. So at this point, we have time 1, time 2, and time 3. In order for 2 people to arrive at the same time, as long as they left at the same time, you would argue that they'd have to spend the same time traveling. So time 1 plus time 2, that's the total time traveling for the first person, will have to equal time 3, which is the time for the second person. Time 1 we've already calculated. Time 2 we've calculated. And time 3 we've calculated. So we have this equation, which is a little bit odd to calculate. So a neat way that we can calculate this problem is simply using our knowledge of finding solutions graphically. So let's go to our graphing calculator, and in the graphing calculator, we're going to Y1, and we'll type in the left side of the equation. So we're going to be typing in 325.6 divided by 2 plus x divided by 5. In Y2, we'll put the right side of the equation, which was just time 3. So if we have the left side of the equation in Y1 and the right side of the equation in time 2, if the left side of the equation is in Y1 and the right side of the equation is in Y2, all we'll have to do is find their intersecting values. All right, so 325, I need a 0.6 there. Let's try that again. The square root of 325.6 squared plus x squared. Now we'll close the parentheses around that, divided by 2, and that should be the right side of the equation. We'll go to the window. We know the window is going to be some values that are quite large because we're talking about x being a distance. And the largest that distance could be is 562.6, and the smallest it could be is 0. It's a distance along the road from where the first person intersects the road to where the old cart was. So it's going to be 562.6, and that was given in the problem. And my y min, I don't think these will intersect at a negative value. These are times. The y values are representing times. So we know the times are going to be quite large in terms of seconds. So I'll go from 0 to about 500. Let's see what happens there. So there's my y1. And now we should have a y2 coming in there. and they do intersect. So I can calculate the intersection. It's asking you for which curves. I want y1 and y2. I don't really have a guess. I'll just hit enter. And there's my intersection at x equals 310.09. I'll call it 310.1. And the time is at around 224.8. So let's go back here. That means that we're going to round that to 310.1, which is the distance. But that's the distance x, which was here to here. So in order to find how far to move the cart, you'd have to take the total distance from the point, the left-hand side of this triangle to the old taco cart, and subtract the 310, giving you 252.